Next, we are going to see how we can create arrays and special cases vectors, all right? So I'm going to start with, we saw that we can use array function to create a list or create a NumPy to a NumPy array or NumPy data type, all right? Let's see what other methods are out there. NumPy offers many different ways of creating arrays, but we are going to discuss two of them in this video. One of them is called function arange, and the other one linspace. All right, so let's see what they are. I'm going to start with a list comprehension, very simple list comprehension. Right, I'm going to say, I want item for item in a range of 2 to 6. All right, and then this is going to I'm going to pass this to NumPy. I'm going to say, give me np data array of that. You are combining Python's list comprehension with NumPy and then pass it to the array. It will work, but this is not recommended, all right? You are not using NumPy's full capability when you are doing this. So instead of that, there is a special function for that called np-data arange. So you have range, all right? If you add just one A at the beginning of it, you are going to get arange. NumPy np.arange of, let's see how it works. I'm going to say 5, right? It is going to say its array of 0 to 4, similar to what you had in range. Next, I'm going to say np data arange of 2 to 7, or 2 to 8. It is going to say, 2 all the way to 7, excluding 8. This is similar to what we had earlier in Python. Can I give it a space and step size? Yes, np data arange of 1 to 6 with step size of 2. So this should give me 1. Let me make this a little bit bigger. 10. All right. 1, 3, 5, 7, and 9. All right. 1, 3, 5, 7, and 9. And these are all NumPy arrays. One special feature, one capability that NumPy has that we don't have that in Python's built-in range function is you can have fractional numbers here. This is what I mean. NumPy np.arange of go from 1.5 to 10.3 with step size of 2.4. All right, you can do this, and it is going to give me 1.5, 3.9, 6.3, and the rest. All right. This is a very powerful function, and we are going to rely on this quite a lot. So try to avoid using list comprehension inside NumPy array as much as possible. All right, you are not taking advantage of NumPy's full capability. Another thing that I'm going to leave it to you to explore is using negative step size. Yes, you can have similar to range. You can have go from right to left as well. You can go from a larger number. The first one could be a larger number, and second one could be a smaller number. Here's one example, and then the rest you can explore. NP data arange of go from 8 to 3. All right. Oh, of course, 8 to 3 with step size of minus 2, right? It is going to give you 8, 6, and 4. You are going step size of minus 2. I'm sure you noticed that the previous one, without that minus 2, it was empty, simply because the default is that your step size is 1. How can you go from 8 to 3 with the step size of 1? So you have to have negative step size. This is one way to create a NumPy arrays using arange function. It's very powerful. We are going to use it quite often. Let's go to the next one. In the next one, we are going to use linspace. Let's see what that is. LNP data, because this is new to us. Linspace. I'm going to just put a question mark in front of it and see what it is. All right. It says it has a start, it has a stop. Num equal to 50. I want you to get used to this. Num equal to 50. What does that mean? It means if you don't provide that parameter, num, default is 50. If you provide a parameter for that, a number value for that, then that number is going to override 50, and that number is going to be used in this function. All right. We have a couple other parameters. Endpoint by default is true. All right. Red step by default is false, and we don't really use this one. All right. So you can ignore it, at least for time being. Let's see what this is. It says return evenly spaced numbers over a specified interval, right? And what is that 50? Let's go down to parameters and read what it is. It says a start, it's starting number and ending number num. Int optional, right? See, it's optional because if you don't provide it, it's going to use 50. Number of samples to generate. Default is 50. Must be non-negative number, all right? This is enough information for us to start. All right, I'm going to clear this output and say np data linspace from 1 to 10. All right, let's see what we are going to get. It is going to give me one. If you count, you have 10 rows and 5 columns. That means you have 50 numbers. Interesting observations here. 1 is included. That's expected. 10 is also included right here. 10 is also included. This is different, right? Instead of using arange, you can use this one, and this one will make sure that when you provide beginning and end, it is going to create evenly spaced numbers for you, right? Distance between 1 and 1.18 is the same as distance between 1.18 and 1.36. It's the same for all of these numbers. All right. Let me use the same thing. np data linspace 1 to 10, and this time I'm going to provide that num which was 50. I'm going to provide another number. I'm going to say give me 5 here, right? And sure enough, it is going to give you 5 numbers. 1, 2, 3, 4, 5. 5 numbers that they all are evenly spaced. Now, what was the other parameters that we have here? I can say np data linspace give me numbers, evenly spaced numbers between 1 and 10, but 1 and 10, 5, and the other one was what? The other one was end point equal to, by default it's true. I'm going to say it's false. All right, and it is going to give you again 5 numbers. They all are evenly spaced. The distance between both on each pair is 1.8. Right, even distance between 8.2 and the endpoint, which is 10. That one is 1.8, but that endpoint is not included. All right. Of course, when you are including or excluding a number, in this case 10, that is going to change the distance. That is going to change and that space between 2 pairs. All right. This can be a little bit at the beginning, could be a little bit confusing, but with a little bit of practice, it is going to get a lot easier. All right. These are very common ways of creating vectors or matrices in NumPy. So let's move forward and look at other functions that NumPy offers, right, for creating matrices. Another function that NumPy offers is np data zeros, right? np dot zeros of and again, if you look at the explanation, it says, you have to give me shape, and you can give me dtype, data type, but you don't have to, because by default I'm going to use float, and it creates all zeros, right? Let's just use it. There's so much explanation there. np, and here is an example, right? It provides an example. np data zeros shape, I'm going to say 4, right? And see what we get. You are going to get a vector of size 4, all with zeros. I can provide np data zeros. This time I'm going to provide shape of I want matrix of a size 2 by 3, 2 rows, 3 columns. 2 rows, 3 columns, right? This is one of you might have a question, why should we create a matrix full of zeros, or a vector full of zeros? This comes in handy in a lot of mathematical calculations, in a lot of our operations, and later on you might modify this, you might change bits and pieces of it, but for time being, we are just learning how we can create these, right? In a similar manner, you have ones, right? Ones, if you read its explanation, it's going to say it's going to create a vector or matrix all filled with ones, right? And it is going to, for example, np.ones of 5, it's going to give you a vector with 5 ones. np.ones of this time, instead of providing just one number, which is going to be size of the vector, I can provide a shape of, let's say, 3 by 4. 3 by 4, right? It is going to create a matrix with 3 rows, 4 columns, all ones. Another way of creating special case matrix is that we have an identity matrix I, right? np.I, it's a identity matrix, is a square matrix that has 1 on its diagonal, and off diagonal is 0. I'm going to say, you know what, np.I of 4. What this is going to do, it is going to create a square matrix with 4 rows, 4 columns, and 4 ones on its diagonal, main diagonal, and then the other numbers off diagonal, they are going to be 0, right? And sure enough, you have that. We talked about zeros, we talked about ones, we talked about I. So there are a couple functions. Now that we are creating these vectors or matrices, next we are going to see how we can work with them a little bit. All right. One of the functions that, let me define an array. Array 1 is equal to, I'm going to create just a simple vector. Let me use np.arange of between 2 to 6, right? And give me array 1, and it's going to say it's a NumPy array 2, 3, 4, 5. Now I can say array 1, oh, my bad, np.xp. I can calculate array underscore 1. I can calculate e to the power of each of these numbers. So that 7.38 is e to the power of 2. The other one is e to the power of 3, e to the power of 4, and e to the power of 5. Another function that we can use is np.max. It's quite often we use this, right? Max of array 1. Sure enough, it is going to give you 5. Another function that I find it sometimes very useful in calculations, especially in probability calculations, sometimes you may end up using that, is a cumulative sum, right? Cumulative sum of array 1. What this is going to do, it is going to provide cumulative sum. So first one is going to be 2, second one is going to be 2 plus 3, 5, third one is going to be 2 plus 3 plus 4, 9, the other one is going to be 2 plus 3 plus 4 plus 5, 14, right? These are functions that we usually use in our NumPy, at least basic calculations. They are very common, and I hope you get comfortable using them.